Alright, in my last video I said that AKMD is equal in size to the nomen NOP. Now we're going to go on. Alright, we have the angle DHM. This is D, this is H, this is M, right here. Okay, can you see that? DHM. And we're going to say that that angle there is equal in size to DEF. This angle right here. Alright. So we mark this right here, and mark this right here. Now, we can already say that this angle right here, which is EDF, okay, EDF, okay, is equal in size to DEF. And you know why? Because line DF is equal in size to FE. And why is DF equal in size to FE? Because we inscribed a square called CEFD. And every one of those four sides are equal in size. Alright. And because of that, since we have now established that angle HDM is equal in size to DHM, then we can actually now say that HM and DM are exactly the same size. Okay? We can also say that because this angle here and this angle here are the same size, and this angle here is exactly the same size as this one, that BD and BH are also the same size. Well, if we go all the way around Mulberry's bush, we can actually finally prove that BD and DM are exactly the same size, because these two are the same size and these two are the same size, so ultimately you end up with a square. And because you ended up with a giant square, you can actually say that BD equals DM because you have a square here. Alright. Now, I know it's kind of weak, but that's basically the point here. Alright. Now, AKMD is actually the rectangle AKBD, because you can actually change this M to a B. So now you have AKBD, and that's because BD equals DM. Okay? Now, if that is true, then we can actually now say that AKBD is equal in size to the nomen NOP. Alright. Now we could go through a whole bunch of rigmarole. We're not going to. We have another square here. It's called LEGH. This is a square. Because this is a square and these are two rectangles that are equal in size, then this becomes a square because of Euclid Book 2 proposition number 4. And we already know that LH equals BC in size because this is a parallelogram and therefore these two lines are equal. Alright, so LEGH becomes the square C, and then we have over here with the H we have B. So it actually, LEGH actually becomes a square of CBEG. Okay? Now, if we were to add the square CEBG, okay, to both AKBD, remember AKBD up here? And we would also add CBEG to the nomen NOP, then we could say that the nomen NOP plus LEGH plus the nomen NOP is equal to CEFD. So the square here plus this gnomon here becomes the giant square CEFD. Alright, but then we can go on to say that AKBD plus CBEG, this square right here, is now the area of the square CEFD. And that's what we were required to prove in the first place. I will tell you more in a future video, so stay tuned.